Hey everyone, my name is Pavankumar Yanamadala. I'm a senior solutions architect here at Amazon Web Services and focused heavily on migration and modernization in my last few years. And I've been helping large enterprise customers navigate their journey from legacy systems to the cloud native platforms. And today I'll be sharing the architecture patterns and the strategies that consistently deliver results. Our session today is Cloud Native Enterprise Architecture for faster digital transformation, building scalable, secure, and resilient enterprise systems. We will cover the why, the what, and how from core building blocks all the way through to practical modernization roadmap. So let's look at the statement why enterprises must modernize. Every organization that I work with are under a consistent pressure to move faster, deliver better customer satisfaction experiences, innovate continuously, and stay competitive in the current climate. But here is the reality. Many enterprises are still running on the legacy systems that are built 5, 10, or even 20 years ago. These legacy systems were not built for today's pace of change. So cloud native architecture is not about putting your old legacy systems or applications in the cloud. It's about building a modern foundation, applications that are scalable by design, resilient by default, and secure from the ground up. And critically, they are built to evolve continuously alongside your business rather than becoming the next legacy bottleneck. Let's look at some of the common enterprise problems as organizations embark on this journey. The first thing is the monolith architecture. So you have got tightly coupled code bases where a change in one module means retesting, redeploying the entire application. A single bug can cascade and take everything down. So another one is the slow delivery cycles. Release processes are like 3 weeks or maybe months following the waterfall approach. So meaning that your team simply cannot respond to market changes at the speed the business needs. The next thing is the scalability limits. So rigid infrastructure that can't scale on demand. You are rather over provisioning and wasting money, or under provisioning and degrading the customer experiences through peak periods. The fourth one is the security grabs. Traditional perimeter-based security models were designed for a world where everything lived inside a data center. In distributed environments, there are critical vulnerabilities exposed, and they're leaving that perimeter for bottlenecks. All right, so let's look at what is the cloud native architecture. So what do we actually mean by that? So it's an intentional design philosophy. It is not just running your old code on someone else's servers. It's about rebuilding applications to fully exploit cloud capabilities from the ground up. So there are 3 foundational principles I just wanted to share on this slide. The first one is the containerization and microservices. They are portable, independently deployable services that can scale independently. The second one is API first and automation. Every capability is exposed programmatically. Every process is automated. No manual gates, no undocumented tribal knowledge. The third and final one is the resiliency by design. Systems are designed to absorb failure without service disruption, because in distributed systems, failure is not an exception. It's the norm. You design for it. Let me walk you through the 6 core building blocks that make up a cloud native enterprise architecture. So the first one is on this list is containers and Kubernetes. Portable packaging for your application, with automated orchestration and self-healing. The second one is the microservices and service mesh. You can independently deploy scalable services as a services within managed secure inter service communication. The third one is the API gateway. So you have a unified entry point for managing routing, authentication, and rate limiting and policies. The fourth one is the event streaming. So where you have a real-time data pipelines built for enabling decoupled and event-driven system integration. The fifth one is integration infrastructure as code. So where you build a declarative version control infrastructure for consistency and repeatable environments. And finally, the observability platform. So where you build a uniform metrics for logs, traces, so that you can proactively measure and improve your rapid incident response. Each of these contributes to a flexible, highly available architecture. So let's go deeper on several of these aspects. So firstly, let's look at the containerization. So containers bundle your application with all its dependencies into a single portable unit. The key insight is what runs in development is exactly what runs in production. So you have that portability and consistency while you're deploying your applications from lower environment to the higher environments. So no more work on my machine failures kind of thing. So the other Docker and Kubernetes gives you is it's an industry standard. What does that do, right? So it gives you the faster deployment, like newer versions can be shipped in seconds, not hours. And it provides a consistent environments by eliminating work on my machine failures and also the drift that causes production incidents. Efficient scaling, spin up or spin down instances in response to demand. So this is the core foundation layer. Everything builds on as you containerize your applications. The microservices architecture, rather than one massive monolith microservices, decompose your business capabilities into independent, focused services, each owned by a dedicated team. The benefits are significant. Independent deployments. Release can release any service without coordinating a full platform deployment. Fault isolation. A failure in one service is contained and protected on overall platform stability, right? The team autonomy. Small teams own services end to end. So that's where, so they can accelerate their innovation cycles by decoupling that life cycle management of that individual components or microservices architecture. And the easier maintenance, because there's very small code bases that gives you the simplification for understanding, testing, and evolve over time. So this isn't just an architecture pattern, it's an organizational pattern. It aligns your technology structure with your team structure. So now let's look at the Kubernetes and orchestration. So Kubernetes has become a de facto standard for container orchestration, and for good reason. It abstracts away infrastructure complexity and automates the full application lifecycle. So it has self-healing, so failed containers are automatically restarted and workloads rescheduled to healthy nodes. And it has another feature called auto scaling. So workloads scale horizontally based on the real-time signals. The third one is the rolling updates. So you can deploy new versions with zero downtime using configurable update strategies. And the fourth one is the service discovery. So which has an automatic DNS-based routing capabilities, so that can route services, can route traffic between services across the cluster. So this gives you an enterprise-grade orchestration with a standard API that works across any cloud provider. So now let's look at the service mesh. As your microservices count grows into hundreds and thousands at an enterprise scale, it will be managing inter-service communications, becoming a critical concern. That's where service mesh comes in. So secure communication, like mutual TLS, encrypts all services end-to-end traffic automatically without touching application code. So your developers don't need to implement encryption. It's handled at the infrastructure layer. The next one is the traffic management. So it's the granular routing rules. You can customize them, you can configure them so that you can shift traffic based on A/B testing or maybe canary deployments, so that can give you an additional flexibility for testing other policies like circuit breaking policies enforced at the infrastructure layer. The third one on the slide is service observability. So it gives you a deep telemetry on latencies, error rates, and request flows that you can measure across every service boundary in a real time. Now let's look at the modern enterprise security construct. So security in a cloud native world is fundamentally different. It's architected in from day one, not bolted on afterwards. Zero trust, never trust, always verify. Every request is authenticated regardless of network isolation. Being inside the network does not make you trusted. So least privilege access. So workloads and users receive only the minimum permissions required to function the specific set of activities or tasks for that job. Encryption everywhere. Data encryption at rest and also in transit, enforced through policies at runtime. And finally is a runtime protection, continuous threat detection and automated response at the workload level gives you more freedom to explore on other security patterns and then implement them within your architecture. The next one is compliance as code. One of the most powerful patterns in cloud native is treating compliance as code. Governance requirements are embedded directly into your deployment pipelines so that policy checks run automatically on every commit and deployment. Infrastructure configurations are valid against regulatory standards before release, not discovered in an audit 6 months later. So rules are enforced uniformly across all teams, all environments, and audit trails are generated automatically. The bottom line, when governance is code, it scales with your engineering organization, not against it. So compliance becomes an accelerator, not a bottleneck. Now here is the practical reality. A complete rebuild is really necessary. Is rarely necessary or advisable. So I want you to walk you through 5 strategic modernization patterns. The strangler fig pattern: incrementally replace legacy functionality by routing traffic to new services over time. The legacy system shrinks gradually until it can be retired. So the next one is replatforming. So move workloads to modern infrastructure with minimal code changes. This gives you the quick wins that deliver value while you plan deeper modernization. Next one is a refactoring. So restructuring entire existing code to align with cloud native patterns and improve maintainability. API enablement. Restructure existing code, wrap legacy systems with modern APIs. This lets you integrate them into new architectures without full rewrites, often the fastest path to value. The last one on this list is a domain decomposition. It identifies the domain boundaries and context within your monolith and extract them as independent microservices. The key messaging here is modernization is a spectrum. So you choose the right approach for each workload based on business value, complexity, and risk tolerance. So now let's look at the platform engineering. It's the term what takes all these building blocks and makes them accessible to your entire organization. So you create a reusable internal platforms that abstract infrastructure complexity. So that enables your developers to focus entirely on delivering business value for your customers. Self-service infrastructure. So it gives you an ability for your developers to provision compliant environments on demand without waiting on operations team or any other platform teams. And it also have that security built up in that in the compliant framework. So they're not deviating or drifting from the secure templates that the platform team has provided for the developers to use. The next one is the golden pipelines. So you are standardizing the CI/CD pipelines with security, testing, and governance built in by default. So teams don't need to reinvent or redeploy any of their products on their own. And then the third one is the golden templates. So pre-approved service blueprints that accelerate new project creation with best practice embedded from the get-go. All right, so now let's look at the DevOps and continuous delivery. So automation throughout the software lifecycle is what separates cloud-native organizations from merely cloud-enabled ones. So from code commit to production, every step is automated, auditable, and repeatable. So code test, build, deploy, operate, it's continuous loop, not a waterfall. So this eliminates manual gates that slow delivery and introduce risk. The organizations that do this well are shipping multiple times per day with higher quality, not lower. A cost is a important element to look in on this cloud modernization journey, because FinOps is a critical piece that businesses care as they're trying to adopt the cloud native architectures. So cloud native success requires on these key element of financial discipline alongside technical excellence. So FinOps brings engineering, finance, and business teams together around cloud value. So this eliminates the wastage of resources, like identifying idle resources, right-sizing workloads, and remove unused services, and continuously, not as a quarterly exercise. And you allocate costs. So tag-based attribution given teams visibility into their actual consumption, and also having the chargeback model will give you additional visibility into the cost. And this so that you can't optimize what you can't measure. So, and then the third one is forecast and plan. So predictive budgeting that aligns cloud spend with product roadmaps and business cycles. So this is a crucial discipline that ensures your cloud native architectures is not just technically excellent, but also economically sustainable. Now let's look at the observability and reliability. So modern distributed systems are too complex for traditional monitoring. So you can't just check if a server is up anymore. Observability provides the deep correlated signals needed to understand system behavior before customers notice issues. So there are 4 pillars underneath this key monitoring and observability reliability platform. So metrics, so it's a time series data tracking throughout tracking throughput, latency, and error rates across all services. The logs is a structured searchable events that enable rapid root cause investigation, so that you don't have to spend too much time trying to get which logs are stored where and all that aspects. So that can speed up. So this can speed up by capturing that logs ahead of time, will speed up the triaging of the issues. Distributed traces, which gives you an end-to-end request flow visualization across every microservice boundary. And the fourth one is the dependency mapping. So in a real-time service topology, revealing hidden dependencies and blast radius is crucial. Now let's look at the enterprise modernization roadmap. So transformations are succeeded when it's an incremental and structured, not a disrupting big bang migration. So every phase builds on the foundation for the next. So let's look at the phase one. So phase one is an assessment where inventorying your existing systems, identifying the modernization candidates, and baselining your current state is a crucial part. So you need to know what you're having and where you are before you can plan where to go. The next phase is the architecture planning. So define your target state architectures, select your technology stack that aligns with your business strategy. The third one is the pilot projects. Validate patterns with low risk workloads, build internal expertise, and generate early wins that will build organization confidence and also build that modernization muscle within your organization. The fourth one is the platform foundation. So you have to establish core infrastructure, golden pipelines, and building security baselines and developer platforms so that you are set for success as you're embarking on this cloud native patterns. The final one is the application modernization. Not only the systematical migration, but also refactoring workloads using the established patterns and platforms gives you that cost optimization and also one step closer to the cloud native patterns. So each phase builds the foundation for the next, skips phases, and you create technical depth that compounds. So best practices for cloud native success. So technology is only one dimension. I have seen technically excellent migrations fail because of organizational misalignment. 4 practices that matter. Business alignment first. So every architecture decision must trace back to the measurable business outcome. If you can't explain the business value, the question, the decision, right? So security by design. So embedded security controls into pipelines and platforms. Never treat it as a post-deployment checkbox. The third one is developer experience. So this one is underrated. So platforms that frustrate developers get bypassed. And then shadow IT starts when the official path is too painful. Invest in tooling teams genuinely want to use, right? And then the final one is the executive sponsorship. So cloud native transformation requires sustained C-suite or your senior leadership commitment to navigate organizational resistance. And all right, so let's look at the future of enterprise architecture. So looking ahead, architecture teams are evolving. Enterprise platforms are evolving towards autonomous, intelligent infrastructure. So AI-assisted operations, machine learning models that predict failures, recommend optimizations, and automate remediations before humans need to intervene. And multi-cloud and edge. So enterprises are not looking at only one cloud provider, but they are looking at multiple cloud providers for various reasons, for regionality, or maybe having a different different cloud providers for the better resiliency. So workloads distributed intelligently across clouds and edge nodes based on latency cost and compliance requirements. The third one is the policy-driven governance. So automated policy engine that enforce compliance, security, and cost constraints across all environments without manual review. And then the final one is the sustainable architecture. So this is an emerging one rapidly because carbon aware workloads, scheduling, and energy efficient infrastructure becomes first class architecture concerns. So this will be significantly an increasing factor in the environmental impact. All right, so let's summarize on what we have learned and what are the key takeaways for you all as you are watching this presentation. So let me leave you with 5 key takeaways, right? So modernize incrementally. So use proven patterns like strangler fig and domain decomposition to reduce migration risks while delivering continuous value to your organization. And do not take a big bang approach by rewriting all your applications into a cloud native platform. And the second one is the scale with confidence. So containerize orchestration, microservices, and elastic infrastructure eliminate the scalability ceilings of the legacy systems. And the third one is accelerate delivery. So create an automated pipelines, establish that platform engineering, and you adopt a GitOps approach for compressing the release cycles from weeks to hours. And the fourth one is the security and governance at scale. So implement a zero trust and compliancy as a code and also policy driven controls so that you can make security as an architectural advantage rather than a bottleneck. And finally, build for future innovation. So AI assisted operations, edge computing, and intelligent automation are already reshaping what enterprises platforms can do. So by cloud native enterprise architectures is not a destination, it's a continuous build capability building journey. So thanks everyone for your time, and I hope you learned something new today. With that, I'll conclude my presentation. Thank you.